Hello and welcome. This is an example to select an impeller of a centrifugal pump based on the demand of the customer. Maybe the demand is going to be the head and the flow rate. Before that, this is according to level of my understanding, and if you need further information, you have to refer further materials. And this figure is taken from Sengel and Simbala text, fluid mechanics textbook. So let's start how we can select the impeller for the demand or for the need. Let me choose the highlighter. So in this case, we have different performance parameter curves. They are in different color. So let's see what each represents. Let me start from the blue curve, the blue smooth curve. It represents the impeller diameter. So when we go up from this point, the smaller impeller diameter is given at the bottom, and it is 111 millimeter. When we go up, we have 203, 216, 229, and 241.3 millimeter, which is the last impeller size for this family of pumps. So in this pump has 1,160 RPM speed, I mean revolution per minute. And for this pump, we can mount these impeller diameters having the same casing. So this can be mounted on a same pump. The problem is, according to the need, the power consumption and the efficiency varies. For this case, we have to choose, we have to be careful which one has good performance, which one consumes less energy or brake horsepower. These points has to be considered. So this blue curve is showing the impeller diameter. The red broken line shows the brake horsepower of the pump according to the impeller diameter. It also varies. The numbers, the quantification can be seen alongside with the curves. You can see 15 horsepower is the largest horsepower given in this curve, and it decreases when we go to the left. Again, we have a green curves plotted. This green curves shows the efficiency when we use that impeller. The first one, in this case, what we see is the 78% efficiency. So it is, we can see from end point to the end point, it is given by 78%, and when we go to the left side, we can see the efficiency is decreasing. Now, okay, one more thing is the required net positive suction head, which is given at the top, and it depicts the required net positive suction head. This purple color shows the net positive suction head reading. This is important when we look to design in avoiding the cavitation, or to make sure the cavitation is to be minimized. Cavitation is the headache in pump design. It is where bubbles form and pitting starts at a location with a low or negative pressure is created. So this purple curve or the net positive suction head can be used in calculating where the pump should be placed above the reservoir. That elevation could be determined to avoid the cavitation. Now for a customer, now one customer may need the flow rate to be 300 gallon per minute and the head to be lifted at 40 feet. For this requirement, let's see which impeller is best, and let's see what efficiency, what brake horsepower, and what net positive suction head is really needed to achieve this. So let me now select my pen. And the first thing to do is now pinpoint your flow rate from the horizontal and the head from the vertical axis. And then after, draw a vertical and horizontal line from these points. I'm trying to draw using a mouse. It's not perfect, but roughly we can understand what is to be done. Again, from the horizontal, I'm going to draw a horizontal curve from the head. And okay, let me do this to the last point. Right. Now this, the intersection point, is our focus interest. This is our focus interest. The head can touch 3 impellers. The horizontal line can touch 3 impellers. It can touch at this point. It is touching at this point. It is touching also at this point, actually. So these pointers, these impellers can lift the fluid up to 40 feet head. So they are capable of achieving this head. And those which are under this horizontal line, which are not crossed by the horizontal line, are not capable of achieving that head. When we come to the flow rate, the vertical line, it is crossing all points. It is crossing at this point. The impeller is being crossed at this point. It's crossed at this point, and it is crossed here and there. So we can have these all impellers to have 300 or to achieve 300 gallon per minute. But the problem is they have their own limitation in elevating the fluid. They have different maximum elevating point or maximum head. The problem is we cannot achieve the head, but we can achieve the flow rate for all pumps. That's why we need to choose the perfect impeller diameter. So, sorry, the point, our interest point is, it was here. It was here. When we go to market, we may not get the exact impeller. So we have to approximate this point to the next higher impeller to achieve the required parameters or to the demand. So I will fix my point at the impeller diameter of, at this point, which is 216 millimeter impeller size. That impeller size is the best. We can also use the next higher 2 impeller sizes, but when we go up, the power consumption increases, and as you can see, efficiency is decreasing. You can see the power. For example, the point is placed in between the 2 power curves, in between the 5 horsepower and 3 horsepower. So approximately, if you consider this by scaling, by partitioning the points, we may get it around 4.5. If you divide this line exactly at the mid, we may get 4. And if again, now it is, the point is between 4 and 5 horsepower. And if we now further divide this at the center, it becomes 4.5. So the impeller diameter that I need for better performance is 12, 200. Sorry, let me erase this. I have 216 millimeter impeller size, and the brake horsepower required for this impeller is around 4.5, and the efficiency is, it is, if you carefully look at the point, it is on the green, on the two green line curves, or the efficiency curves of 74% and 76%. So it is approximately to the 74%. Maybe we have to take it using the ruler or using a precise measurement system. But roughly, I can say that the efficiency is around 74.5, because it is nearer to the 74. And if you divide a midpoint for this also, maybe this can show us 75. And if we again divide these two in between the red line now and the green, we may get 74.5. The other one, the one left, is the pink, or the net positive suction head. Now come to this point and draw a horizontal line from that point. Draw a horizontal line from that point. And at the end of that line, we may get these readings. This reading from 0 up to 10 is the net positive suction head. So I can say that 4 feet is the net positive suction head. So net positive, the NPSH is simply 4 feet. So these pointers are the performance characteristics for this impeller diameter. So now we are confident enough this impeller diameter is best for the demand, for the customer demand of 340 rate and head requirements. If you want to further increase the size of the impeller, it will need further power consumption, and also the efficiency is decreasing. So why do we need to increase the power consumption and to decrease the efficiency while we could have the best point at the lower impeller size? Okay, so this way we can fix our design or our selection criteria. Thank you.